Have you ever watched the rain and noticed how some droplets connect and some don't? It seems like there's no way to tell what's going to happen next, but what if we could? Imagine two dots, which we can call nodes, and say there was a 50% chance that a line would form between the two. If we make a few more of these nodes and let the random phenomena play out, we now have certain connected blobs, which are called open clusters. Open because a connection is made, and it's like opening a pipe that water can flow through. If we change these to squares and keep letting this occur, we get different shapes and sizes of open clusters and empty void. But if we change the probability of a bond forming, this can make a huge difference in our resulting network. Say the probability is 0.1. Then only 1/10 of the graph would be clusters. And if our probability were 0.9, we'd have one cluster as the majority. Well, this makes sense. If there's a higher chance of an opening, we're going to have more spaces that are adjacent and are able to be connected. In between, one of our blobs grows exponentially to become the majority. If we narrow in on this point of rapid growth, we find that this critical point, the phase shift, occurs at a probability of 0.5. Where clusters that gradually grow are suddenly overshadowed. This boom is where small random occurrences converge into large events, like a light drizzle to a flood, or a few COVID cases scaling to a pandemic. Take Alzheimer's. Memory loss is caused by deformed proteins that cloud the connections between our neurons, the network of our brain. These deformed proteins are able to weaken hub nodes, which are areas of the brain with a lot of connection. Because these pipes are open, they act just like open clusters. The likelihood of whether the protein is able to attack can be mapped out with the same probability values that decided the percolating behavior we saw earlier. With this mapping, researchers are able to identify the next targets in the brain, allowing them to provide more personalized treatment and earlier diagnosis, effectively saving lives. While no model is perfect at predicting real life, percolation theory helps us make sense of the random phenomena in our lives.